In this video, we're going to talk about linear inequalities in word problems. Let's take a look at this example. Miss Smith, the head librarian at the elementary school, can spend less than $75 to expand the children's section of the library. When she buys from a particular discount seller, paperback books X cost $3 each, and hardback books Y cost $5 each. So let's highlight the most important information in this problem. We have less than $75. Paperback books X cost $3. Hardback books Y cost $5. And we need to write an inequality in the standard form to represent this scenario. So we know that each paperback books X costs $3. So that's X for the cost of paperback books. And then we know that each hardback book, Y, costs $5. So we're going to write the cost of the hardback books as 5Y. Now, the cost of the books is supposed to be less than 75 because Miss Smith cannot spend um, any amount of money that is equal to 75 or greater than 75. So this is the inequality in the standard form. To be able to graph this inequality, I need to put it in the slope by intercept form. And to be able to do that, I need to take away 3x from both sides of the inequality, which makes me end with 5y less than negative 3x plus 75. Now I need to isolate the y, which means I need to divide by 5, divide all sides by 5, and I'm going to end up with y is less than negative 3 over 5x plus 75 divided by 5 is going to be 15. So to be able to graph the inequality, as we said before, after we put the inequality in the slope by intercept, we need to identify the parameters, which is the slope and the y-intercept. So the slope in this case is going to be negative 3 over 5, and the y-intercept is 15. Now remember that B, which is the y-intercept, stands for begin. So when you begin graphing, you need to start with 15. So I'm going to start with 15, the y-intercept right here, and I'm going to use the slope to find another point on the line of this inequality. So I'm going to, based on the slope, I'm going to go down 3 units and over to the right 5 units. So I'm going to end up with this point, 5, 12. And then do it again and find the next point. Do it again and find the next point until I cannot graph anymore. So based on this inequality, as you can see, I have less than, which means every time you have less than or greater than, you need to graph a dashed line. So I'm going to graph a dashed line between these points. Now I also have less than, which means I need to include every single y value less than the values that I have on the dashed line. And I can identify which side I need to shade if I look at the y-intercept. I need to include every single y value less than the y-intercept, which is in this case below the line. So any point in the shaded area is going to be a solution for this inequality. The points on the line or the dotted line is not going to be a solution for this inequality because they're not included. So let's answer the question after that. What is the maximum number of books that Miss Smith can buy if she needs 7 paperback books? So I can solve this question in 2 ways. Algebraically, by substituting x with 7, which makes me end with 3 times 7 plus 5y is less than 75. 3 times 7 is 21, plus 5y less than 75. I'm taking 21 from both sides to isolate the y. So I'm going to end up with 5y less than 54. Now, to find the final answer, I need to divide by 5. I'm going to end up with 5 is less than 10.8 books. Now, we never had zero point 0.8 books. So, and since we're saying y is less than 10.8, that means 10 hardback books. That's the maximum number of books that Miss Smith can buy if she buys 7 paperback books. Now, this is algebraically. Graphically, if we look at 7, which is supposed to be um, around here somewhere, we're going to end up with a solution of 10. Because as you can see, so we're going to try and find the solution for 7. So 7 on the x-axis is right here. And if we follow 7 to find out what the y value is, it's going to be closer to 11. But again, we're not including the numbers on the dotted line, so it has to be 10 right